Hello friends, my name is Prasad and in last lecture we have learned about measurement systems. So today we are going to learn about scalar and vector quantities. So what are scalar quantities? Scalar quantities are the quantities which can be represented only by magnitude. Okay, basically to represent scalar quantities only magnitude is required. And what are the vector quantities? To represent vector quantities, magnitude as well as direction is required. Okay. So to explain this, I will give you one example. Say this is you and your friend, okay, you and your friend, and your friend tells you that from this point at a distance of 60 kilometers, there is a treasure. What he told you, from this point at a distance of 60 kilometer, where 60 kilometer, there is a treasure, but you don't know where. So it could be here, it could be here, it could be here, it could be here. So for that, let me draw a circle. Okay, and let us consider this as the center of a circle. So what will happen? The treasure could be here at a distance of 60 kilometers. The treasure could be here at a distance of 60 kilometers. Treasure could be here at a distance of 60 kilometers. So treasure basically could be anywhere on the circle. Okay, anywhere on the circle. So uh, so what has happened? That was a distance, right? So distance of a 60 kilometer. Here, what your friend told you? Your friend told you that at a distance of 60 kilometers there is a treasure, but he doesn't tell you about he or she doesn't tell you about the direction. So you know only the magnitude. What is 60 kilometer at a distance of 60 kilometers? It's a distance. So what is the distance? Distance is a scalar quantity. What? Distance is a scalar quantity because it doesn't need the direction, right? But now your friend tells you that at a distance of 60 kilometer east, where east, at a distance of 60 kilometer in the direction of east, there is a treasure. Now you know this is the east, this is the west, this is north, this is south, right? Now you are very much clear where is the treasure. From this point to the east, here is the treasure, right? Right, here is the treasure. Now you both of you move from here to here and get the treasure, and you, both of you are very happy because you got the treasure. So what happened? You moved from this point to this point. So what exactly you did? You covered a distance. You could cover a distance of 60 kilometer, a magnitude of 60, you covered 60 kilometer. And in which direction? In the east direction you covered the distance, right? So you move from this point to this point. So what has happened? Displacement has happened. To represent the displacement, what you need? A distance of 60 kilometer, that is a magnitude, and the direction east. So you require magnitude as well as direction, right? So that's why the displacement is a vector quantity. That's why displacement is a vector quantity. Got it? Now I will give you one more example to understand the difference between distance and displacement. Say this is you. Okay? Say this is you. And you are very happy. You are going to your friend's house for a party. What you are doing? You are going to your friend's house. Your friend's house is here for a party. But the road to go to your friend's house is like this. It's a very complicated road. Okay, so you need to cover this much distance, right? And this much distance you need to cover. Say this distance is 120 kilometers. Yeah, your friend stays in a nearby city. So the distance is 120 kilometer. This distance is 120 kilometer. But you needed 2 hours for that, right? How much time you required to move from your house to your friend's house? 2 hours. So in a distance of to cover the distance of 120 kilometer from here to here, you need 2 hours. Okay, but what is the displacement that has occurred during that time? What is the displacement that has occurred during that time? So displacement that occurred is from this point to this point. This is the displacement. What is displacement? Difference between the distance, basically difference between the final destination and your starting point. The distance between your final destination and your starting point in a straight line is basically your displacement. So the displacement is 60 kilometer. Okay, for our simplicity we are taking these figures. So distance that you covered is from this point to here, right? And the displacement that you covered, that displacement that occurred is 60 kilometer, and it required 2 hours. Okay, so did you get the difference between distance and displacement, what exactly it is? Now I will give you one more example to understand these things in detail. Suppose you and your friends are here. Now you got the treasure, you are here, and you would like to find more treasures where there are more treasures on this circular path. Okay, so both of you start from here. This is the starting point. You start to move like this, this direction, this direction, this direction on circular path, and again you came here at the starting point. So how much distance you covered and how much displacement has occurred? Can you tell me? Your starting point is this, your ending point is this. So the difference between the distance of starting point and ending point is 0. So displacement is 0 here, but the distance you covered is this circular path. Okay, so that is the difference between distance and displacement. Now we will understand more in detail about speed and velocity. We will learn about the speed and velocity. What is speed? Speed is equal to distance upon time, right? What is speed? Speed is distance upon time. The distance. Now we know the distance is a scalar quantity, right? Distance is a scalar quantity because only magnitude is required to represent the distance. So what will the speed? Speed is also a scalar quantity because distance is a scalar quantity. Speed is also a scalar quantity. So we will write it here that speed is also a scalar quantity. Because distance is a scalar quantity, speed is also a scalar quantity. Now we will learn about velocity. What is velocity? Velocity is equal to displacement upon time, right? Velocity is displacement upon time. What is displacement? Displacement requires magnitude as well as direction. It's a vector quantity. So what will be the velocity? Velocity will also be a vector quantity. That's why the velocity is a vector quantity. Say, see, the speed. You can say that the maximum speed of my bike is 120 kilometers per hour, or say 150 kilometers per hour. So that is the speed. That doesn't require the direction. Okay, but for the velocity you need a direction. So we have learned about the speed and velocity today. Now you can solve this problem. The distance you covered to go from your house to your friend's house to your party is 120 kilometers, but the distance covered is 120 kilometers. Time required for this is 2 hours, right, to reach here. But the displacement that has occurred is 60 kilometers from this point to this point, right? So you can calculate the speed. Now in the MKS system, the units are meter, kilogram, and second. So you have to convert this distance of 120 kilometer into meters. So what is 1 kilometer? 1 kilometer is 1000 meters. So you can cover and write. You can solve this problem by yourself on the paper. The time required, we need the time in seconds. So 1 hour is so 1 minute is 60 seconds. 1 hour is 60 minutes. So you have to do that. So time is 2 hours will be equal to what? I will write it here for your simplicity. What is the time? The distance you can calculate. It's easier. The time will be 2 into 60 minutes into 60 seconds. So that will be the time. So So you have to solve this problem. Thus, obviously, the speed will be higher and the velocity will be low because the displacement is only 60 km. So that is the difference between the speed and velocity and the scalar and vector quantity. So what we have learned today, just understand about the scalar and vector quantities, why it is required. Uh, we need to understand about the difference between the scalar and vector quantities and speed and velocity. Okay, so in the next lecture we will learn about acceleration, we'll learn about the force, inertia and frictional forces. Okay, thank you very much for your cooperation. Welcome.